All right. So with function operations, I'm just talking about straight up adding two functions together, subtracting two functions, multiplying two functions, dividing. It's going to be a specific type of division. We're not going to do a whole lot of major division with functions, not until unit 3 at least, and some scalar multiplication. So all of this stuff probably sounds like you've never done it before, but when I actually start doing it, you'll be like, oh, okay, I remember at least seeing this before, just in a different light. All right. So, how this is going to work is they gave us these two functions. F of x is 3x plus 2, and g of x is x squared minus 2x plus 10. We are going to be using these two functions exclusively for all of these problems on the table. So I'm going to show you how to do it with adding functions, subtracting those two functions, multiplying those two functions, etc., etc. All right. Now, we're going to start first with adding functions. So the notation for adding two functions together, you will typically see it like this: f plus g of x. That's how you say it, f plus g of x, which is literally just add f of x and g of x. All right. So what I'm going to do first is just write them out. Now, I typically tell you guys to write these in order, but not necessarily for adding functions. Order doesn't really matter for the adding. But when we get to some of the other operations, the order does matter. So rule of thumb, just write them in order as you see them. So if we see f first, we're going to write f of x first. So I'm just going to write out 3x plus 2, which is f of x, plus x squared minus 2x plus 10. And that's g of x. Now, does this kind of notation look fairly familiar to you guys? So our next step in this case is to simplify. And I don't mean solve for x or anything crazy like that. I just mean simplify it down to one singular function. How do you think I'm going to do that? What kind of pops out to you? Like that niggling feeling in the back of your head, like what's kind of popping to you when you look at what I just wrote out? What's your gut feeling that you should do? Combine like terms. Good. So when you're adding functions, it's one of the easiest operations ever because all you're doing is combining like terms. That's how you simplify it down. So this lesson is all about simplification, not solving. Two very different things. Simplifying means that we're getting it down to another expression. Solving means we're actually trying to get a number. All right. So when we're combining like terms, can someone raise their hand and tell me what makes a like term a like term? How do we know if two terms are like terms? So how do we know that two terms are like terms? So 10 and 2, for example, is definitely a like term. But how do you know they were like terms? You guys don't have to overthink it. Just right, they're just numbers. They didn't have any variables after it. So that's one set of like terms. What's another? 3x and negative 2x. How do you know those are like terms?
Because it both has the same variable.
Right, they both have the same variable. But why is x squared not with them? Because it's raised to the second power. So what qualifies a like term is it has to have the same variable, same exponent. All right. Now, when we combine like terms, we only add the coefficients. What do I mean by coefficient? The number before the variable. Good. So we already said that 3x and negative 2x are like terms. We said that 2 and 10 are like terms. And x squared is just kind of on its lonesome, but we can't really leave it out. It's just by itself. So what I typically like to do, like what I just did, is in order for me to kind of organize my like terms, I like to either highlight them different colors or I draw different shapes around them. So like, for example, the 3x and 2x, I may draw a square around them. The 2 and the 10, I may draw a circle around them, and I may draw a triangle around the x squared. So I know that, okay, yellow goes with yellow, square goes with square, circle goes with circle. All right. It's just a good strategy to use to just kind of get yourself organized. Now, I like to write out my functions in standard form. And now you've probably heard about it before, but I'm just going to remind you what it is. So standard form, all standard form is means you go from the highest exponent to the lowest. So in other words, you put the terms with the highest exponent first, then the next one down, then the next one down, until you get to the constants. Because technically, 3x has an exponent of what? If you just have a singular x, what's the exponent? 1. If you have a constant, what's the exponent? 0. So that's why it is what it is. So if we're going from highest to lowest exponent, what term am I going to put down first? X squared. It's going to bring down the x squared. Just because it's by itself doesn't mean it's not important. All right? We're just going to bring it on down. Now, what should I combine next? The yellows or the greens? Based off of if I want the next highest exponent. Yellow. So the x's. So what's 3x minus 2x? Just x. Or 1x, however you want to state it. Remember, again, we're only adding or subtracting the coefficients. And then we just slap an x on at the end. All right? So 3 minus 2 is just 1, and there's an unspoken 1 in front of that x that I just wrote. Lastly, we have the constants. So what's 2 plus 10? 12. So I would say f plus g of x is equal to x squared plus x plus 12. And that would be my answer. Now, that's adding functions. Pretty straightforward. If you know how to combine like terms, you'll be golden on adding any function. All right? Subtracting functions is very similar to adding. You're still combining like term land. But there's one other thing that we have to do before we can combine like terms. So we're subtracting functions. We're still combining like terms. Also, another thing to note when you're subtracting functions, the order of the functions matters. Meaning, if you don't put the correct function first, your answer is going to be off. Why does order matter when it comes to subtraction? Why do you think order matters when it comes to subtraction? Right, because that could be the difference between your answer being negative or your answer being positive. For example, 2 minus 1 is 1. 1 minus 2 is not 1, it's negative 1. They're not the same answers. All right, same numbers were used in that statement, but depending on the order depends on what our answer is. Addition, it doesn't matter the order, but that's just because if you do 2 plus 3, that's the same thing as 3 plus 2. All right. So I'm going to go ahead and write out my function. So we're going to do f first because we had f minus g of x. So f came first. We're going to write f's function first. So 3x. I can't talk today, guys. So 3x plus 2 first minus x squared minus 2x plus 10. Now, why did I write g of x in parentheses? I did for a reason. Why do you think I did it? Someone who has not taught today. Yes. Sort of. You're kind of on the right track. So the x squared is positive instead of negative. What do we typically associate with parentheses with something outside of it? What do we typically do? Right, we would times whatever's outside of the parentheses inside, or we would distribute. What's the unspoken number out here? 1. If it has a minus in front of it, it's technically negative 1. So the reason I put that whole function in parentheses is because it reminds us to distribute the negative to all the terms in g of x. Otherwise, the subtraction won't work. So you have to distribute the negative first. All right. So before you can even touch combining like terms, you got to distribute that negative. And it's just as simple as multiplying all three of these terms by negative 1, which if we multiply anything by negative 1, what's really the only thing that happens? The signs flip, right. So in reality, if you think about distributing the negative, all you got to think about is, okay, I just got to flip the signs. So I would now have 3x plus 2, because that was not within our distribution, so we just bring it down. X squared now becomes negative x squared. What does negative 2x become? Positive 2x. And positive 10 becomes negative 10. Now that we distributed that negative, we can determine our like terms and combine them just like we did up top. So can someone tell me one set of like terms? 2 and 10 again. So 2 and negative 10. So make sure you include the signs with them as well, because again, it's important. All right. What's the other set of like terms here? 3x and 2x. And then our negative x squared is back in the singles club, but still got included. It's just fifth wheeling. All right. Now, if I want to state this from highest exponent to lowest, what's first? So what's the first value that I would state first, or the first term that I would combine? Or not combine, but just bring down? The negative x squared. Good. Then I would do the x's. So what's 3x plus 2x? 5x. Just do 3 plus 2, slap on an x. Now what's 2 minus 10? Negative 8. So f minus g of x would give us that function, negative x squared plus 5x minus 8. Any questions on adding and subtracting functions? So again, it's fairly straightforward. All right. The only difference between the two is subtracting, you just got to distribute that negative first. So my suggestion to you, get in the habit of putting parentheses around your second function. All right. Even if you're just adding, it may still be a good idea to put parentheses around, just so you know that they're two separate entities. All right. So now we're going into multiplying. You've still seen this before. We're still in a land where you've seen all of it before. All right. Or you should have, you know. I know I didn't have y'all for math too, so I don't know. All right. It's in the curriculum, and that's what I'm going by. So If you see f times g of x, it just means you're multiplying the two functions together. So I'm going to go ahead and write them out. So I'm going to do 3x plus 2 times x squared minus 2x plus 10. And I'm going to use parentheses in this case to signify my multiplication because it's just cleaner. All right. So we're using parentheses to signify multiplication. Now, what does that look like to you? What method kind of rings in your head that would help us? You've probably seen something that looks similar to that at the very least. So think back to Math 2, Math 1, all right? You did this with polynomials specifically. We actually did a version of it in our warm-up today. So what method do you think will help us multiply these two functions? You could. So you could do almost like a FOIL method. With this one, however, I think FOIL is better when it's like a two-term, just because there's less room for error. You could totally FOIL that, but it gets dicey because more often than not what happens is you miss one term and then your answer's a little bit off. But there's another way too that's just a little bit more organized. So FOIL's one way. What's another way? That's FOIL. So guys, when I was factoring earlier today, I did a reverse box method. Why did I call it a reverse box method? Because I was undoing that multiplication. So what method can I use to multiply? Box. All right. So box method is typically the one that I would go with for this one. So whenever you multiply, I highly recommend the box method. Now, if you like to FOIL, that's well and good. Like if you want to do 3 times all of these and then 2 times all of these and then combine the like terms, you totally can. It just gets dicey. All right. Box method is pretty much the exact same thing. It's just a little bit more organized. All right. So how you set up your box, you look at the number of terms. All right. So I'm going to make a box that has 2 rows because I have one function with 2 terms. And then my second function has 3 terms, so I'm going to make 3 columns. So my box is going to look like that. And then outside, I'm going to write each term outside of a row or column. So 3x plus 2. And I like to write the signs with it just so I keep up with them. And then on top, I'm going to write x squared minus 2x plus 10. Now, this starting to ring some bells for you guys now? All right. So, how do I get what I need inside the boxes? So this is where the actual multiplication comes in. How do I actually work the box method? So like fill in a singular box. So like for example, the first one, the top left corner. What would I do? How do I know what 2 terms I'm multiplying together? So if I'm trying to fill in, for example, this box, all right, what two terms do I need to multiply together to fill in this box? 3x and x squared, right? So in other words, you multiply, if you're looking at the singular box, you multiply it by the row it runs into and the column it runs into. So for this one, you do 3x times negative 2x. This will be 3x times 10, and so on and so forth. All right? Now, what is 3x times x squared? You're close. So it's 3x something. So when you multiply to the third power, good. So remember, when you multiply just numbers, so two terms, you would multiply the numbers by themselves. So 3 times 1, that's 3. Then you multiply the x's together. So x times x squared. Remember, so when it comes to x squared and x, remember when you're multiplying exponents together, all you're doing is adding them. So x has an unspoken exponent of 1. 1 plus 2 is 3. All right. So this would be x cubed. So you multiply the big numbers together, add the little numbers. What about 3x and negative 2x? So we're now doing the next box over. Negative 6x squared, good. Unspoken 1 here. Negative 2 times 3 is negative 6. 1 plus 1 is 2, so it'll be an x squared. What about the next box over? So this far right one. 30x. If there's no x on one, but there is on another, you just slap that x on. We can't just kind of eliminate it. What about the next row down? So this one right here. 2x squared, 2 times x squared. What about this one right here? Negative 4x, good. And then the last box, 20. 2 times 10. So again, be careful with boxes because I know sometimes you want to either combine like terms or add. Just remember you're multiplying. All right. I make that mistake sometimes too. I've definitely done that before. All right. Now, once we got the box filled in, it's just a matter of pulling it out of the box and combining like terms. Now, if you don't want to have to rewrite all of those terms and then combine some more, kind of save you some paper space a little bit, a little trick that I like with box method is, and this typically is the case for almost every box method, almost, it's not always, but typically your like terms are diagonal from each other. So the x squareds are diagonals from each other, and the x's are diagonal from each other. The x cubed and the constant are by itself. All right. That's typically how it is for any box. There are exceptions to that rule, so don't quote me on that, but it's a little trick for sometimes it works. It's a good thing to check if it does. All right. Yes, sir. So in reality, it doesn't matter. As long as you know that, okay, I have 3 terms, so they gotta go, so in some way I gotta have either 3 rows or 3 columns. You could have totally made your box like this. And then the 3x here, the 2 here, x squared minus 2x plus 10. You could have done that, gotten the same answer. All right. I typically like to put the one with the most terms on top. That's just my personal preference. If you like this, that's your thing, right? But you would have gotten the same answer. As long as you make sure the terms are in order that you see them. So like the x squared first, you put the x squared on the first row, and so on and so forth. Now, if it was like a 2 by 2, it doesn't matter. All right. Does that kind of answer your question?
Yeah.
So we're going to pull everything out to get my final answer. So f times g of x will equal, if I'm putting this in standard form, what's the first thing? 3x cubed. Good. Then come my x squared. So I already got them circled together. So let's just go ahead and combine them. What's negative 6x squared plus 2x squared? Negative 4x squared. Then my x's. What's 30x minus 4x? Positive 26x. And then I bring down my 20. So this would be our new function if we multiplied those two together. So again, you could have totally foiled that and got the same answer, but like I said, me personally, I like box method because it's just more organized. It's easier for me to see. If you like foiling better, to each their own. All right. But just know that with foiling, the only kind of Achilles heel, specifically if you have a 3-term or bigger, is that there is a chance you may miss a term. It's really good for a 2x2, but once you get bigger than a 2x2, like you can do a 2x3 or a 3x3, it gets a little dicey. All right, because you kind of forget, okay, did I already multiply this term to this term? And it's a lot. All right. But again, there's more than one way to cut an onion, so whatever is your preference, whatever you're the most comfortable with, go for it. All right. Any questions on multiplying polynomials? All right. Now, dividing polynomials. So, dividing polynomials we are going to do a lot more with it in a later unit where we're actually going through and making calculations and everything. But with dividing, it can be fairly straightforward. So, if we have f divided by g of x, it's just f of x divided by g of x. So I'm going to set this up, and I'm going to set it up like a fraction. So my f of x will go in my numerator, and my g of x will go in my denominator. Now, we'll learn in a later unit that you could try and factor the bottom to see if anything cancels out. That's the only way we can really go into dividing it. Because we can't do 2 divided by negative 2x because of that minus, and that's connected by the other terms by pluses and minuses. So typically in math, multiplication and division, I like to say it's almost like an open relationship. They're okay with swinging between different things. You know what I mean? Whereas pluses and minuses, that's like a good old-fashioned marriage, like Catholic don't believe in divorce. You can't separate them if you tried. All right? So that's kind of the rule of thumb. When it comes to dividing, if it's being multiplied, you can get rid of it. If it's being added or subtracted, you can't. Yes, ma'am. Yes. So in reality, because of that fact, we're done. This is our answer. All you got to do is just put it in that fraction form. Now, the last one that we're going to do is scalar multiplication. All right. So a scalar, all a scalar is, so that's some vocab for you right there. All a scalar is a number multiplied to an expression. So literally, if it's written as a times f of x, all we do is just multiply that to it. So for example, you may see it like this. Let's say a is equal to 2. You would see 2f of x, like that. That just means you take f of x and you distribute a 2 to it. That's all you got to do. All right? And that's just an example. So for example, I'm going to do it with a first, and I'll show you with 2 as well. So if we have a times f of x, so 3x plus 2, all we got to do is distribute. And since we're associating a with a number, we're just going to tap it on to both terms. So 3ax plus 2a. Now, I know sometimes if you throw another letter in there, it can kind of get confusing. So I'm also going to show you. So that was af of x. But I'm also going to show you the 2f of x example. So, and that's the same as 2 times f of x. So off to the side, we're going to do a more numerical example because sometimes seeing the actual concrete example makes a lot more sense than if you see the theoretical. And trust me, I'm the same way. If you give me the theoretical, it takes me a hot minute to decipher it. But if I see a concrete, you put some numbers in there, I'm like, okay, I get that. Okay. So we're going to do 2 times f of x, so 3x plus 2. And that's just simple distribution. So 2 times 3x is 6x. 2 times 2 is 4. So that would be what 2 times f of x would be equal to. All right, so if you ever see a number next to like the letter of a function, that just means multiply it by that number. So distribute that number to the entirety of that function. All right, so trying to figure out what I want to do because we got farther than second period. Okay, we'll come back to evaluating tomorrow, mainly because your exit ticket is similar and I just want to see what you guys come up with. All right. But we're going to do some other examples. So look on the next page at number 17. Yes, sir. Yes. Oh, you know what? Yeah, let's just take a break. That'll kill some time. So 5-minute break. So be back before that timer goes off. Which one was it? This one? You're welcome. Sorry, still in the class? Okay. I was about to say. Like, you went from 22 to 19. I was like, that's 3 kids. But when I didn't see you, when I saw you, I was like, anyway. Yes, sir. No, you did exactly right. That's exactly what you did.
So it's supposed to be like
So sometimes they'll throw in like a expression like that, and you just plug it in for the next. Yeah, same concept. Good job.
okay, so now this would be -9, -9, -3. That'd be -10.
Just put them on my desk. Thank you. Yeah, that's fine. All right, my darlings, 5 minutes are up, so let's get back to the grind. Actually, you know what? There's only about 10 minutes left anyway. So